Thank you. Yes, my name is Alexander Cordes. I'm from Trondheim, and before that, Canada. My Norwegian is quite bad, so I have to do this in English. I'm gonna talk about building your own makerspace for really cheap. So a lot of people want to make makerspaces. There's a lot of costs involved. We can talk about how we can do it in a really cheap way. So first, let's talk about creativity. NASA did this creativity test where they asked people, how many uses can you find for a paperclip? Of course, lots of people say, hold paper together, but they actually found that 5-year-olds could find hundreds of ways to use a paperclip. They didn't see a paperclip, they saw a piece of wire that could be used for anything. They had a huge imagination. So we call this divergent thinking, thinking of all the different possibilities, not converging on ideas, but diverging. So 5-year-olds, 98% of them ranked in a genius level for creativity. And then they tested the same kids when they were 10, and it dropped. And then when they were 15, and it dropped. And they also tested 1 million adults. The adults, 2% ranked in this genius level of creativity. So for me, a makerspace is a lot about bringing this creativity back. If you're older than 5, you should go to a makerspace and bring this creativity back. So, for me, a makerspace is about bringing creativity back and the joy of making new things. And I feel like if it's too expensive, too high tech, that becomes a barrier. It becomes not accessible. So I think things should be simple and cheap so people can be creative. It's a lot about thinking about lots of creative ideas without judging them. Think of all the ideas without saying that's not gonna work, that's not gonna work, that's not gonna work. Because that's what kids do. A 5-year-old doesn't have the experience to say all these things aren't gonna work. They think of all the possibilities. And adults too quickly say, no, that's not gonna work, or that's not gonna work. And they also found that fear and anxiety really reduce creativity. Your whole brain shuts down and you're not able to be creative. So in these makerspaces, it's very important to support students so that they can reduce their fear and anxiety to be creative. So my whole idea is to start with an empty space. Hopefully it looks a little bit better than that one up there. But you just have an empty room, and that's your makerspace. And then together with students, you build the machines and you build the tools as cheaply as possible. And setting up the makerspace is part of the making, right? You're a maker, so you can make things. So you might as well make the makerspace. You don't have to go and spend $100,000 and buy all these fancy bamboo printers. You can build your own printers. And in this way, having less money makes you more creative. You don't need lots of money to be creative. Having less money can enable creativity. And schools often have free rooms, partially free, or sometimes they have rooms that are always free. They could be a makerspace, but they're waiting for people that know what to buy, and they're waiting for the money to buy the equipment. So we can use e-waste to build stuff. So e-waste is just all the old electronics that nobody wants anymore. So here's a picture of I call it now a 2D printer. I think they used to be called printers, but now I call them 2D printers. And then these are all the parts that are inside a 2D printer. A lot of stepper motors, gears, linear rails, a lot of good stuff that you can use for 3D printers. Then there's a picture there of my homemade 3D printer that I made out of wood and the cheapest components. And here, any student can look at the printer and see how it works. It's not all covered up in a box. It's all accessible. It's all really cheap. So they can try and make a 3D printer that breaks, and they can try again. Makes it very accessible. And then having large donations of cardboard from like the IKEA or whatever store across the road. Having large donations of wood for the makerspace. That's all great building materials. And also really good to have a relationship between like the e-waste company and the makerspace so that they can bring lots of CD players and whatever with motors, parts that they could use. So if you have a makerspace where people are building low-cost materials, these are things that can really make a difference in the world. If your students in the makerspace build something like solar cookers or wind turbines from cheap materials, that can be built in other parts of the world for cheap. So now you're thinking about how you can make an impact in the world with what you're making. And just quickly, like my whole makerspace philosophy is kind of thinking about what to focus on. So I believe that This is the opposite of what a standard teacher would focus on. So in a makerspace, I'm focused on the feelings of the students, how they feel. Are they anxious? Do they feel comfortable? The next one is the process. How are they using the engineering design process? What happens if they get stuck? What happens if they get too frustrated? Do they know when to take a break? Do they know when to go for a walk to be creative? Then it's the skills like programming, math, engineering, which schools focus on. And the last one is a good final product, whatever they're trying to build. I don't think the teacher cares about that at all. It's more about the process. But that's usually driving the students. And in a standard school, the good final product, the answer on the test or the final project is usually the only thing that matters, no matter how they got there in the process or how they feel or how stressed they were. Just really quickly about some of my projects. People always come to me and say that, oh yeah, you can't use e-waste, you can't make anything useful from garbage, but these are examples of my battery recycling. So I take the old laptop batteries that have these 18650, like the Tesla cells, and I test them all, and the good ones I use in projects, and the bad ones get ground down. I think that's the way to recycle. You have to test the batteries first, you can't just grind them all down, because there's good batteries there. Like a laptop battery in that picture there usually has 6 cells, and it's always 2 cells that die, and the other 4 are usually strong, because it's the way they're wired in series and parallel. So here I built an e-bike battery, and here I have a drill like this one. So this is a dead drill that used to use nickel cadmium batteries, and then you just take battery cells from the garbage and glue them in, and I've been using this drill for 3 years every day, and it's a great tool. And you can find hundreds of these in the garbage, because when the battery dies, the rest of the drill is perfectly fine, so it's a big waste. Yeah, and then it ended with me making an electric bike from dead laptop batteries that has 100-kilometer range. You can sit on this bike, you press the throttle, you don't pedal at all, and you'll drive 100 kilometers without charging. So it has this huge battery. I think it's 1 kilowatt hour, and it's just like completely free out of garbage. If you went to the store and bought that battery, I don't know, it would be 2,000 euros or something like that. So, yeah. So, yeah, I'd like to bring more recycling into makerspaces. Thank you very much.
Excellent, Alex. And when you're not here talking, they can find you where? You're downstairs?
Yes, I'm the pool
down in the lobby. So if there's anything you want to ask Alex, you can ask down in the lobby. Okay, so next up.